Okay, let's look how Timer0 can be used to generate and control servo motor. So you have to remember again on servo motor, it needs this type of wave to control the positions of the servo motor. So for example, you must have this whole period is at 20 milliseconds, right? So you must have total up for this period is going to be 20 milliseconds, and the pulse must be at 1 milliseconds for the case of 0 degree. And for the case of 90 degree, you have to have the pulse at 1.5 milliseconds and the same period of 20 milliseconds, and which is the same case for the 180, you have to have a 2 milliseconds. So this is where Timer0 can be used. So if you can try code here, it's also in the module, but in the module it's using port A, so you have to change it a bit because port A you have to set whether it's digital or analog, so it doesn't matter. We can look over here on the code here. So for Timer0, of course, you must use the option right here. For the case here, you are setting up this one as 1/2 for the prescaler. And then I'm going to use thrice B because I'm using port B right here, port B just now, to look at the results here, right? And then we can look at the first condition for the port B is all high, means that you have the signals all 5 volt first, right? And then this one you can remove this one in con for my yeah, no need for in con. Yes, you have to use it because it's interrupt, so you are going to enable the Timer0 interrupt. And this is a new one for you. This is a CNT count. It's actually a parameter, sorry, it's something that variables which you introduce here to count something like here, because this is unsigned count CNT, and then your Timer0 start from 0. So this is a normal one we have learned just now. Right now, what happened in the program? All right, so the interrupt here, okay, if you go here, the interrupt will be based on the Timer0 counting up to 255, right? So once the 255 go back to 0, the overflow conditions is happening, is happened, right? So it will go to the interrupt version here. This interrupt will increase or add 1 CNT plus plus, mean is going to be like this, CNT plus. Okay, in C++, if you have the CNT plus plus or any variables, right here, draw. So just now it's a CNT plus plus, means that once it's go for this particular command, right, the CNT starting from 0 in the first place is going to be +1. Then the value now is going to be CNT is equivalent to 1. That is the increment, sort of increment. So you look at this command again. So once the interrupt happen, right, it will go up here and increase the count value from 0 to 1. And then this command is only to check if the count is 200, then you have to reset back the CNT back to 0, and you have to pull up all of the what do you call that, all of the port B status. So what does that mean? So it means that if the count is not yet 200, then the port B is not going to be FF. Means that right now you are looking at the program of here. Let's how to draw this one. Okay, here let's draw this one. Okay, for this case, right, so you already start up the port B as a high state here, right, high state. This is 5 volt and this is 0 volt. You have start here from 5 here, and then when the Timer0 is counting, you are going to do that one, and interrupt happen, it will go up here, and then you can see here is plus plus, right, means 1. Nothing happened, it will go down here and go back to your interrupt, sorry, the while one, and then it still maintain this one up to CNT is equivalent to 10 here, because every time the timer 0 interrupt, you will go up and increase the count here 1, and then go up again 2, 3, 4, 5, because this is not going inside here, 6, 7, 8, 9, 10 here. Now if count is equivalent to 0, then you have to pull down port B pin F0 to 0. So means that you are going to pull down here. After count is equivalent to 10, you pull down, and then again the process happen again, still counting here, right? 11, 12, 13, blah blah, 100, 199, 200, and then it will go inside here. If count is equivalent to 200, then you are going to reset the count back to 0, and then this is going to pull up the port B. So it means that after a while is going to be pull up the signal again, and this is where the count is equivalent to 200. This is 10. So if you run this code, right, if you run this code continuously in while 1, you can see here the value is going to be like this. Here I'll show you just now, it will be like this. So how to calculate this count and this count 200? So right now, try to calculate based on the code just now we have. Right. So prescaler is 2. Right. Prescaler is 2. So right now the timer 0 is 0 to 255 times 255 times 1 instruction cycle for this one 20 megahertz is 200 nanoseconds. And you also need to count how many counts from here, because remember that every time the looping here is based on how many counts here. For example, just now, one time here, this is only 10 times, right? You have to count, go here, back again. Every time the interrupt happen, it will go up here and then up to 10 times. Not only one interrupt happen, you calculate. This is only one interrupt. So right now is you are checking up to count is equivalent to 10, so you must times 10 over here. So that will be the time needed. All right, so let's look at the calculations here. 2 times 255 times 200 nano, right, times 10 count. This is going to be 1 millisecond. Right, this is going to be 1 millisecond. This is 1 millisecond. So same goes to like this one. Value just now in your value here is around, yeah, 1 point, around 1 something is 1 here, 1 milliseconds. All right, so how will be the period here? Remember that from this case just now, right, from this count. So this is 200, right? So instead of 10, this is going to be at 200. Right, so 200 means it's going to be, instead of 10 here, right, oh sorry, this is not going to be this one, 2 times 255 times 200 nano times 200 count, and the result is 20 milliseconds. You can go for this engineering is 20 milliseconds. So total here to here is 20 milliseconds, and you can control the servo motor based on this waveform. So how to get this one and this one? So you can do some changes on the code, like this one for example. You can write down, hold on, here you can write down another count calculations. For example here, this one should be, if count is equivalent, else, if else, then else if you have, because there are 3 conditions, right? So else if CNT is equivalent to 15, this is going to be 1.5 milliseconds. All right, then you're going to turn on port B dot F1 is equivalent to 0. This is pull down. We are going to have the result later in the oscilloscope. And then last one is else if count is equivalent to 18, then we are going to do the port B dot F2 pin number 2 to 0. Then you can run the code. This is something here which is I need to double check. So this is no semicolon. Alright, this is also semicolon. Run this one. Okay. From the protest here, there are 3 pins, right? So we can take this pin here, and also we also can look at this pin. Then you run this one. You can see the value here is different. This is a 1 millisecond. This is 1.5 milliseconds, and the last one is 2 milliseconds. Which these types of wave you can control the servo motor. So let's try to put a servo motor. Servo motor. Right here, and this one here, and this one here. Then you can just get this one. Then you have the power and ground. Power. Ground. Alright, so this is going to be the controlling of the servo. So so we need to check this one. Just double check this one. Okay, based on the results here, the signal is not like the very accurate like we do it in the lab last time, where you just control by using delay. This one we still have some error over here. This one should be negative 90 degree. This one should be 0 degree, and this one should be 90 degree. So there is actually some error on this particular simulation. Because we just know that we can prove that the, what we call that, the oscilloscope here, right? Just now the checking for the oscilloscope is we have the signal correctly, but in terms of the simulations of the servo motor, it may not accurate like when we do the last in the class last time for the servo. So you can use the method like we learned in the class, or you also can use this method to control the servo motor. Okay, thank you very much. See you guys next time.